So the only thing that we really need to work on today is if you're given the x value, just convert it to the z-score. So that's the only thing that you really have to look at today, and there's a simple formula right here that does that for you. So other than that, everything is identical the same from yesterday. That's why we took some time to look over today, as far as looking up the table, knowing how to do the less than, the greater thans, and the betweens. All three will be on today as well. But first, just looking at this situation here, one of the main reasons that we like z-scores is that it lets us do something that is generally referred to as comparing apples to oranges. So you can compare two different things that are two different scales, more or less, and actually know which one's better or which one's worse. So, for instance, they have the ACT test, which I think the highest score on the ACT is 35, and the highest score on the SAT is 1600. So if you get two scores, like he got a 27 on the ACT, and then he got a 1150 on the SAT, which one is better? Right? You can't look just at these two numbers and say, oh, 27 is better than this, or 1150 is better than this, because they are graded on two different scales. Well, what we can do is convert them both to z-scores, and then they'll be on the same scale, and you for sure can tell which one is better, which one is worse, based upon which z-score is higher. So that's one of the main reasons we like z-scores, and we like that normal curve, is because it puts everything on the same scale. Doesn't matter what question we're asking. We're going to be asking about heights or weights or scores on a test. It puts everything on one scale, the z-scale. So it's a pretty powerful tool and very helpful for selling arguments. If you're like, well, which one's better, and they're on two different scales, you can actually figure that out. So we have, for you guys here, the mean. Remember, this is mu. That stands for the mean. These will be given to you, and here the standard deviation, sigma, that will be given to you. So all you have to do is take the x values from the problem, 27, plug it in, and then separately do 1150, plugging in, and find out which one gives you a higher z-score. Okay? And you can see here on both of these, they give you the standard deviation and the average for ACT, and here's the average and standard deviation for the SAT. Okay, so just take 27, right, minus the mean, which is 20, divided by 5, standard deviation. Plug that in the calculator and see what decimal you get. Okay, go ahead and do that. All the problems you need a calculator. It's not like a, sometimes you will, sometimes you won't. Basically every single time we'll need it. So this comes out to 1.4? Okay. So of course, this is 1, 2, 3 using the z-scores, -1, -2, -3. So 1.4 is about, well, this would be 1.5, so I'm going to go a little to the left to make 1.4. Right there. So that's pretty good, knowing the average is, where 0 is. And don't forget, we started doing these normal curves with just the standard deviation, the mean. So you could always go back to, using 20 for the mean and then going up by 5 for each of these. So this is 25, and this is how we originally started. So we have two scales going on here. If we're just doing one question, we could use either. But when we start doing two questions and comparing, we absolutely need the z-scores. Okay. So just keep that in mind. We have an x scale, and we also have the z scale. Sometimes both work, other times you need the z-score. So 1.4. So now we want to do the same thing for the SATs and see is that bigger or smaller than 1.4, and then we'll know if the SAT or ACT is a better score or not. So here we got 1150, right? On the SAT, average is 1,000, standard deviation is 200, so that comes out to be 0.75. And this is 0, this is 1. So 0.75 is right here. So who did better? I mean, sorry, which test is better? Which one's higher, 1.4 or 0.75? Yeah, so we have ACT. ACT because 1.4 is bigger than the 0.75. Higher z-score means did better. If you want to look at it as percentile, we could actually look up on the z-score table and find out what the decimal is, and that's the percentile that he scored for each of the tests. So what percent he was better than. So here, definitely more than here. Okay, I think let's just skip to part 2, just to give you guys a little more time. So again, the only difference here is from yesterday is that they're going to give you the actual X value, right? Not the z-score itself. So first thing you need to do is convert whatever X value they give you, and of course X is less than 50. That way you know it goes into the X part right here. So that X and this X are the same thing. So 50. And for you guys, it's going to always give you the mean. Just scan the question for the mean and standard deviation. If this was an actual stats class, you might have a problem where you would have to find the mean and standard deviation yourself using the stuff that we did before on how to calculate that. But for here, we'll just give it to you so you can practice more problems. So the mean. All right. So the top gives us how much better or worse we did than the average, and then dividing by the standard deviation gives us the z-score. So 50 minus 4 divided by 7 comes out to negative 0.57. So now we can convert. We just went from plugging in the x value, right? And we got an answer of z. So we have z now less than negative 0.57. And since it's a z-score, we can look it on the z-table and find the answer. We can't do that with 50 because that's an x value. Of course, 50 is not even on here, so it wouldn't make sense. So using the table, what do we get for negative 0.57? So use the table here. It's going to be negative, so it's going to be on it. There's a negative and positive side. There we go. So negative 0.5 there. And 7 right here. Alright, so they intersect right there. So we got 0.28434, it looks like. Which is about 28.4%. Right? And negative 0.57, that'd be right about here, be negative 0.5. There we go. All right, so yeah, this looks like it's about 28.4% or about 30%. If I got a big number like 40 or not 40, like 50 or 70 or something, I'd know that's wrong because that wouldn't be matching the graph. Remember, from 0 to the left or right is half, 50%. So I know just by looking at this, the answer should be for sure less than 50%. So about 30, that's about right. And just like the homework yesterday, there are some that are less than, and you can just look up on the table because the table gives you less than. It doesn't give you any greater than. So when you come to a greater than problem, remember you have to subtract it from 1. So we have to do 1 minus x less than 70. Anytime you have a greater than, that's when you have to do the 1 minus, because our table only gives us less than. Okay. And our table only accepts z-scores. This is an x-score, so convert the x-score to a z-score. We have 70 minus same mean, 54 divided by 7. And again, always nice to have a calculator handy for all of these. 70 minus 54, 16 divided by 7. 2.29. Pretty big z-score. So now from here we'll have 1 minus p probability of z less than 2.29. Right, so we change out the x, turn it into a z. Now we have z less than. And since it's a z less than, you can look up on the table, find 2.29. Okay. 2.2 is right here, 0.9 right here, 0.09. So we're looking at 0.98899. Doing a little subtraction here. So I get 0.01101, which is about 1.1%, very, very small. And we expect that with 2.29 z-score. That's a pretty big z-score. I mean, our z-scores basically go up to 3, so the closer you get to 3, the less likely it's going to happen. So here we go. 2.29 would be right about here. Yeah, we're just talking about this tiny little part that's underneath the curve. Okay. And lastly is just like the third problem from the homework. It's between two numbers, right? So we have one that's less than, one that's greater than, and then the between. Those are the three types. So we have, remember with between, you use the double inequality, less than x less than. So when you say this, just you don't really say the probability of 40 less than x less than 45. You just say the probability between 40 and 45. So we'll do this, remember, two ways, two probabilities here. We want to find less than 45, subtract less than 40. According to that last column on your homework, that's how all these are. So the bigger number is going to be first here, because you always want to do big minus small to get a positive number. If you do it in reverse, you'll get a negative answer, which doesn't make sense. When you're talking about area, you can't have negative area. Right, so just like the ones before, these are both x-scores, so we have to convert both of these to z-scores and then compare. And it's all the same standard deviation and mean that we're using. So instead of 50 or 70, we're just swapping out that one number to get a different z-score. We got 40 minus 54 divided by 7. Oh no, 45 actually. 45 minus 54 divided by 7. For this one, right, that's 45. And then for this one's 40. 40 minus 54 divided by 7. There we go. 45 minus, oh, I did it again. 40. Oh yeah, that's right. 45 minus 54. Negative 9 divided by 7. Negative 1.29. Minus 40 minus 54 divided by 7. Negative 2. There you go. Now, do notice I'm doing 40 minus 54, hitting enter, and then dividing by 7. If you just do 40 minus 54, and then divide by 7, notice how you don't get the same answer. Because it's dividing 54 first, it's doing order of operations, it's doing division, it's doing 54 divided by 7, and subtracting that from 40, which is not what you want, right? If you really want to do it all in one step, that's when you use the parentheses. So if I did 40 minus 54, right, in parentheses, of course, parentheses is before division, so it'll actually subtract those two and then divide, and that'll give you the right answer. So the parentheses do matter with order of operations. Of course, if you're doing a z-score and you got an answer of 32, you got to look at this and say that can't be right. Z's are between negative 3 and positive 3, so it'd be impossible to put 32 here because when you go to your table, right, the z's do not go up to 32, so you'd know something's wrong if you ever got a number too big or too small there. All right, so just look up each one of these. Negative 1.29 comes out to, I have it here, 0.09853. And for less than negative 2 would be 0.02275. Those are both from the table. And then, of course, do the subtraction. You get 0.07578. Which is roughly 7.6%, very small part, very small piece. We can check that here. So negative 1.29 is about right here, and negative 2 just right here. So yeah, indeed, between those two is a very small piece. There we go. So it does match. That's a 6 right there. There we go. So majority of this, right, from this point on, is all the review. The only thing new here was using these formulas right here to convert them to z-scores, and then it's just a review problem that you had on your last assignment. And you'll find out that tomorrow's assignment is very similar to this too. So you have basically everything you need to know for your test. So everything up to this point with anything statistics. All right, let me just finish them up. So big minus small. So we're going to do less than 75 minus less than 65. The z-scores will be 75 minus 54 over 7. And 65 minus 54 over 7. So my two z-scores are 3. And here we're going to get 1.57. So z-score of 3 gives us basically 100%, 0.99865, and subtract that from the z-score of 1.57, which is still pretty high, 94179. And just so you can see this a little clearer, right, we're going from 3, which is, again, basically the very end, and 1.57, which is right about here. So between those parts, very, very small. And indeed, if you subtract these two, you'll get 0.05680, which convert is about 5.7%, which does look about right. This is a very small part, so we expected a small number. Okay, so there you have that. You can go ahead and start number 24, I think, is the next assignment in the packet. You can start that. You have everything you need to know to do number 25 as well. If you want to do 24 and 25, that's fine. 26 is up here hanging. That's just the review for your test. We'll do some more problems tomorrow, but the next 2 days will largely be work days to make sure you know everything you need to know. If you feel like you really got this stuff down, go back to the very beginning, look at like the 5-number summary, find the Q1, the Q3, just review that stuff because it's been a few weeks since we've done that. But overall, very doable test that people usually do on average a lot better on this test than others. So if that being the case, put in some extra studying time, you can get a really high grade. All right, and you guys have the rest of the period. Get to work.